Hey guys, Survival here. Today, I wanted to address a topic that affects a lot of people. Whether you're a photographer, an engineer, a researcher, a content creator, or a prepper, we all have one thing that affects us in common, and that is huge volumes of data that needs to be stored and protected. Specifically, it needs to be protected against loss. And what we mean by this is data redundancy. We need to eliminate the single point of failure. Single points of failure traditionally have been things such as floppy disks, USB sticks, external hard drives, and the like. Commonly, people will use anywhere from a 4 to an 8 bay NAS, network attached storage, in order to store their data. The benefits of a NAS are you have storage that is available in the form of a network drive across your entire network, according to whatever your local network security policy is, and which users have been authenticated and authorized to access each different network drive. NASs allow you to have multiple drives working together, usually in a thing known as RAID. This allows you to have some redundancy. The amount of redundancy available will vary depending on the RAID type you enable. Generally speaking, 1 to 2 drives can fail as long as they are not critically dependent upon each other. The other benefit to a NAS is the fact that you can have huge amounts of storage, commonly 10 to 20 plus terabytes worth of storage. If, however, this is not enough space, there are other options. For example, going to a more enterprise type solution, such as a solution similar to what a lot of people call a FreeNAS box. This is a server rack mount case, usually with 25 hard drive bays in it, and it usually runs server hardware. The main reason that these types of solutions run server hardware are because they need huge amounts of RAM. Commonly speaking, rack mount enterprise type NASs utilize things such as the ZFS file system, which requires huge amounts of RAM, well and truly beyond that of a standard consumer motherboard's capability. The issue with this option is the complexity involved in setting these solutions up. A lot of things that are aimed at enterprise are still aimed at experts who have been highly trained and are extremely knowledgeable about using complex command line operating systems. However, the benefit to a solution like this is expandability. A lot of your more enterprise solutions can be scaled. When one unit fills up, you can simply add another unit, join it together, and continue expanding and having more data storage, limited only by financial constraints and physical configuration and storage constraints. However, sometimes it's not the most cost-effective option because you still need a lot of physical hardware and it will draw a lot of power. So one other option people have is to simply move their data off-site to things such as data centers. However, this can pose a challenge, as some types of data are not allowed to be taken off some premises. Generally speaking, a lot of engineering data has to remain on site. If, however, you don't want to risk your data potentially being leaked or breached or acquired through some sort of hack, when none of these options are suitable because you primarily need to store a lot of data, but you don't need to access it often, cold storage is the only solution remaining. And it can actually be the most cost effective, even though it requires a lot of upfront investment. What we mean by cold storage is offline, unpowered storage of data. Similar to Betamax tapes, there are data storage tapes, known as LTO tapes. These tapes can each, in the current generation, comfortably hold 12 terabytes of data per tape. The tapes can be easily duplicated and they can be stored in a library known as a tape library, which, if you can afford it, can be fully automated. They don't have to be, they can be manual, and you can be responsible for selecting the correct tape. There are, however, rack-mountable tape libraries that can hold anywhere from 8 to 12 tapes, all the way up to huge, fully automated tape libraries, basically infinitely scalable, limited only by your financial constraints and the physical space available. The benefits to cold storage on tape are, tape has a very long life, commonly up to 25 years or longer. There are very few moving parts inside a tape, therefore there are fewer points of failure. The tapes do not have to remain powered in order to hold the data, and each tape being able to hold a huge amount of data means you do not need anywhere near as many to back up your data. Further, by being compact and light, you can easily store them, send them between sites. However, tape has one downfall, and that is you cannot readily access your data if it's on tape. The entire tape would have to be read and copied into RAM before files can be accessed. And generally speaking, to put files onto a tape, you need to prepare a queue of files and then have that entire queue written to the tape. So whilst tape has its benefits, data access is the negative with it, which is why tape is commonly used for what we call cold storage. So if you're a photographer or a content creator or an engineer, and you have terabytes of data that you need to keep for reference purposes, it could be a past project that you need to keep in case you need to go back to it or refer to it, but you don't need to access it regularly, you can offload it to tape. Tape is also a really great way to back up your entire NAS. If you're uncertain that your NAS will not get damaged, or if you think there's a chance that it could have a huge failure and all your data be lost, you can choose to back the entire NAS up to tape. There's nothing stopping you other than your finances. As I said before, tape solutions are very expensive, commonly ranging $15,000 to $20,000 for a read-write tape drive, and small tape libraries can be $20,000 plus. Some older ones are available through auction sites online. However, it should be noted that older generations of LTO tape have significantly reduced capacities than the current ones, commonly anywhere from 6 to 7 terabytes per tape, unlike the current 12 to 14 plus terabytes per tape. A lot of people would think, hey, if I put my data on hard drives in something like a NAS, I could just power it down and leave it. Come back 25 years later, power it on, and there's my data. But one of the things that's commonly overlooked with mechanical storage is things such as lithium grease, bearings, parts. These things are all potentially prone to some sort of failure. And what happens, for example, if a hard drive or some sort of backup NAS that's been turned off for a long time gets dropped and damaged? If the platters get scratched, your data's gone. If a drive motor fails or a read head motor fails, your data's lost. Sometimes it can be recovered if the platters are intact, but generally speaking, there's just too many points of failure. At least with tape, your data is there, and at worst case, there's only a reel or wind mechanism to fail, which can be easily fixed if needed. So basically, we have the following options: a small home NAS, an enterprise NAS, usually rack mounted and highly scalable, offloading our data to a data center, or offloading data that is ready for cold storage to tapes. The main considerations are: what is your budget? How much scalability do you need? And do you need to actually keep the data? Whilst you might think data is important, if you sit down and make a list of the reasons why you should keep it and the reasons of why you don't need to keep it, you may find out that some of your data is not as important as you initially thought it was. Sometimes the data can be compressed. However, there does come a point where you do have to offload a lot of data to cold storage. And unfortunately, the options are limited. Cloud storage does also have limitations, such as, depending on who you're with, how much space you're able to actually have. But the biggest, and by far the most restrictive limitation of cloud storage is the upload speed for most people. Not everywhere in the world has high-speed internet, especially here in Australia. We have very slow internet comparative to the rest of the world. And if you're needing to back up several terabytes worth of data, you could be at it a very long time. So it's not always the most practical solution. Lastly, one question that Bushcraft and I would love to have your input on is: what's a great way physically have a whole bunch of information readily accessible for reference, but still keep it relatively transportable in a grid down scenario? Please leave your thoughts and comments about that down below. Also, remember to like and subscribe to help keep this channel growing. And remember, stay safe in the bush.